Okay, so it's always a good day when you can do a math word problem. And I have a nice, lovely little math word problem right here. Let me actually go ahead and read this thing to you. It says a pump rated at 25 gallons per minute is used to empty a 15,000 gallon pool. How many hours will the job take? So this is the problem. If you understand the problem and you can actually solve this thing, go ahead and put your answer into the comment section. But let me just clarify something here, just in case you're confused. A pump rated, okay, so what does this word mean? Rated at 25 gallons per minute. This is the capacity of the pump. So if you're not quite sure what this meant, like rated, what does that mean? Well, this is what the pump can do, all right? This pump is capable of pumping out 25 gallons per minute. All right, so there is the problem. Again, if you think you could do this, put your answer into the comment section. I'm gonna show you actually the correct answer in just one moment, and then we're gonna get into how to solve this problem. But I don't want to give you too many clues right now because I want to give you an opportunity to get this thing right and to make some common mistakes as well. Because a lot of students are gonna answer this question, and they're gonna answer it confidently, but they're gonna be incorrect. So let's go ahead and see how well you do here. But anyways, before we get going, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades, not years, but decades. I absolutely love teaching mathematics. It is my true calling, and I'm telling you right now, all of you could be successful in mathematics, and I'm especially speaking to those of you that struggle in math or have a tough time with math. Listen, if you failed math class or if you're failing right now, you can turn this thing around. All right, that's my my message of hope to you. But you're going to have to work hard, right? So I'm not going to kid you and say, oh, you could just do it magically. No, as long as you're willing to work hard and you have some encouragement, but most importantly, great math instruction, like math instruction you actually understand, clear, understandable, and comprehensive, then you could be successful in mathematics. If you need help in your current math course, or maybe you're getting ready for some sort of special test that has math on it, I'm talking about things like the SAT, ACT, GED, GRE, GMAT, ASVAB, Teacher Certification Exam, or if you're homeschooling mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span these categories and much, much more. I'm also going to leave links to my math notes in the description as well because a lot of you out there that are math students do not take adequate notes. All right, you take some notes, some days you take notes, some days you don't take notes. And if you do take notes, oftentimes your notes are sloppy. It's very common. I was a terrible note taker way back in the good old days, but it's impossible to be successful at math unless you take great math notes. So improve your notes and everything will get much, much better. But in the meantime, you can use my notes if you like. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and answer this word problem. But before I show you the answer, let me give you a quick little reminder. When you're tackling any word problem, I'm going to tell you the first three steps. Step one is to read the problem, which is obvious. Step two is to reread the problem. And step three, again, is to read the problem one more time and make sure you understand the question. And how do you know where the question's at in any problem? Look for the question mark, okay? Not to be funny about this, hey, go to the question mark and then back up from there. So we want to know how many hours will this job take? Well, let's go ahead and give you the answer right now. Okay, so it's going to take 10 hours to pump out this 15,000 gallon pool using this particular pump. Now, if you got this right, let me give you a nice little happy face, an A plus, a 100%, and a few stars so you can celebrate your awesomeness in math today. Nice job. Now, here's the deal, right? The way I'm going to solve this problem may not be the way you approach this, okay? And that's perfectly fine as long as you can justify your conclusion. So if you got the 10 hours, what you can't do is be like, oh, I did this all in my brain. I just did a bunch of mental math, or like, I just knew how to do this. That's not going to be adequate in terms of, if you're going to be a math student, okay? Or even if you're not a math student, you're just interested in solving math problems. You need to get good at justifying what you did. Okay, so basically, like solving a math problem is very much like like a lawyer, in a court. They're like they're in front of the judge, and the jury. They're like, okay, this and this, I prove to you that this is the answer. Okay, and here's my case I'm making to you. So you be the judge. Am I right or wrong? That's the kind of way you need to look at solving math problems, is justifying your conclusions. Okay, and there's different ways you can approach it, but as long as everything you're writing down is logical and correct, then that's perfectly fine. So if the way I do this problem is like, "Oh, I didn't do it your way, but I got the right answer," that's fine, as long as you can, again, put it on paper so someone else can read and be like, "Oh, I understand what you did and why you got your answer." So again, when you're doing these practice exercises, write stuff down. Just don't get your calculator out and do a bunch of number crunching. But anyways, if you got this right, that's fantastic. Let's go ahead and take a look at the problem. So I already told you the first three steps of a math word problem. Read the problem, read it again. A lot of you out there will read the problem once and you'll start doing things. Don't do that. Really make sure you understand what's going on. So this particular word problem, let's just read it one more time. A pump rated at, i.e., this pump's ability is can pump 25 gallons per minute, is used to empty out a 15,000 gallon pool. Okay, so I kind of understand that situation. How many hours will the job take, i.e., how long does this pump need to run, this 25 gallon per minute pump need to run to empty out this 15,000 gallon pool? Now, after you read a math word problem or an algebra word problem, anything like that, you want to try to model the situation. So oftentimes it's helpful to draw a little sketch, kind of like translate the words, the sentences of the word problem into something a little bit more visual. That's very useful. So you could even do something as simple as this. So draw yourself a little pool. There's 15,000 gallons. We want to empty this pool out with this pump. That this pump can pump out 25 gallons per minute. So here is some observations here, right? So this pump's rating, its capacity is given to me in gallons, right? I know I can take out 1 gallon per minute. So that's a really important concept. I'm dealing with gallons here and dealing with gallons here. Anytime you're working with a math word problem and there's things like there's units involved, right? Units of measure involved, like feet, inches, miles, gallons, hours. You need to be on high alert for units of measure. That's going to have a big, big impact. I'll talk more about this a little bit more in the solution to this video, but this is a little bit of a reminder here because we are dealing with gallons per minute, right? So anyways, maybe some of you kind of know where I'm going here with this. But let's kind of take a look at our pump information. So we're being told that this pump can pump out 25 gallons per minute. That's how you would say that, right? 25 gallons per minute. And this word per, anytime you see this word per, where else would you see the word per? For example, how about this? 70 miles per, okay, 70 miles per hour. Whoops, per hour. We don't write it 70 miles per hour. We typically write it this way, mph, 70 miles per hour. So we're dealing with something called a rate, okay? So if I asked you, hey, what's the rate of that truck going down the road? And you said, you would interpret that word RAT, rate, as what? As speed or velocity, and you would be correct. So the rate of the truck, for example, could be 70 miles per hour. But we need to kind of really understand when we're given a rate, how do we kind of really break that down? Well, so let's go ahead and take a look at this example right here. So 25 gallons per minute. So the word per is like a fraction bar, okay? So 25 gallons per 1 minute, 70 miles per 1 hour. You could write it this way, for example, but really what you're writing is 70 miles per, there's that line, 1 hour. You want to express these rates as a fraction. And the technical definition of a rate in mathematics is it's basically a fraction where the numerator and denominator have different units of measure, okay? So here, what's the unit of measure For our numerator, it's gallons, which is what? Volume. Okay, so that's volume. We're comparing volume with what's this unit of measure down here? Minutes with time. Okay, so we're comparing two completely different units of measure. That's called a rate in mathematics. So here we're comparing distance and time. Of course, that's miles per hour. All right, so there's another related concept called ratio. And anytime you're dealing with rates and ratios, you want to be thinking about proportions, okay? So the deal here is this, when you read this problem, you know that you're given some sort of rate. So go ahead and express it this way. That's going to be kind of a hint on how to solve this problem, okay? And math problems, there's, basically patterns associated with it. But if you have a math problem and there is a rate or ratio in it, you want to be thinking proportion. So let's go ahead and set up a proportion to solve this problem. Now, some of you may not have set up a proportion exactly in this way. You probably, did some number crunching and were able to get the right answer. That's perfectly fine. Again, as long as you can, outline and express your conclusions in a logical manner. But this is really what you want to do. You want to set up a proportion. So a proportion is two equal rates or ratios or fractions. That is a proportion. So if I have one rate and it's equal to another rate, that is what we call a proportion. But again, for those of you that are not quite sure what a proportion is, it's one fraction equaling to another fraction. So for example, if I have the fraction 1/2 and I said, hey, give me another fraction that's equal to 1/2. Well, there's a ton of them. How about 5/10? Okay, so 5/10 is equal to the fraction 1/2. When you have, this is by definition a proportion, two equal fractions. Remember, a rate is in itself a fraction. So two equal rates or two equal ratios, a ratio is a fraction as well, is a proportion. And when you have a proportion, you have something called the cross product. So this is 1 times 10 is 10. That's going to be equal to this product crosswise. 2 times 5 is 10. So 10 is equal to 10. The cross product is true. So just in case of those of you out there a little bit rusty on proportions, when you have a proportion, you're going to use the cross product to solve proportion problems. I'll get into this a little bit more here in a second. But anyways, let's go ahead and use this rate that we have, 25 gallons per minute. So we know this pump can pump out 25 gallons per minute. Notice where the units of measure at. I have gallons in the numerator and minutes in the denominator. So what you want to do is set this equal to 15,000 gallons per X minutes. Okay, gallons again are in the numerator, and minutes we don't know. But basically it's this. If this pump can pump out 25,000 gallons per 1 minute, it's the same. This is proportional to the pump pumping out 15,000 gallons to this many minutes. Okay, so this fraction or this proportion is equal to this proportion. We're just pumping out more gallons here. We can do 25 gallons per 1 minute, and we can do this proportion is the same as doing 15,000 gallons to this many minutes. Okay, so I really want you to understand what a proportion is and why we can use them. All right, so if you understand what's going on, again, be very careful when you're setting up proportions. If this is gallons and this is minutes, this up here has to be gallons and this has to be minutes. All right, so let's distill this down into just a basic proportion problem. So this would be 25/1 is equal to 15,000 over x. And of course, we want to solve for x. And how are we going to solve for x? Again, we're going to use that cross product. Whoops, I didn't want to do that. Let me use my little highlighter here. All right, so 25 times x is what? 25x, and that's going to be equal to 1 times 15,000, which of course is 15,000. So how do I solve for x? I'm going to divide both sides of the equation by 25. I get x is equal to 600. But what is x? Well, let's go back up here to make sure we understand. X is minutes, all right? X is that unknown that we solved for, but its unit of measure is minutes. So we just solved the answer. It's 600 minutes. Now, if some of you were just in a rush, and a lot of students will do this, they'll be all happy. They're like, look at me, I can do proportions, and they'll write 600 down as their answer. Okay, sometimes they'll just write 600, sometimes they'll write 600 minutes. But what was the question? Well, let's look at the question one more time. The question says, how many hours? Hours, not minutes. So you got to convert minutes to hours. All right, this is where it gets students get themselves in trouble. And a lot of you are probably saying, please don't tell me to read the problem again and again and again. You say that so many times. Well, listen, I'm telling you that I'm being redundant because this is where a lot of students go wrong. They know how to do the math, but then they answer the wrong question, okay? Or they're like, this goes too quick. They forget, hey, am I answering the right question? So anytime you're doing any math word problem, when you're done, go back and re-look at that question carefully. Be like, all right, am I given the answer that the question is asking? So hours, how many hours, not how much time. If the question was how much time will the job take, you could say 600 minutes, but we want to know how many hours. So let's convert minutes to hours. So 600 minutes, how many hours? Well, just take, there's 60 minutes in 1 hour. So somebody could just say, oh, that's 600 divided by 60, right? And that's exactly correct. That would be 10 hours. But let's just take a little bit closer look at converting units of measure, because this is important. Although this example is pretty easy, what's technically going on here is we have 600 minutes. We want to go from minutes to hours. So anytime you're converting any unit of measure, you want to know what we would call a conversion factor, okay? So the conversion factor that we want to use here is 1 hour per 60 minutes, okay, or 1 hour to 60 minutes. In other words, there is 1 hour for every 60 minutes. So notice here I have hours and minutes, but there's 1 hour per 60 minutes, but also there's 60 minutes per, let me actually do this right here because this is a very important detail, okay? So we need to have what we call a conversion factor. We can express this as 1 hour to 60 minutes, or 60 minutes to 1 hour. Okay, so 60 minutes per 1 hour, or 1 hour per 60 minutes. So these are both correct, right? And we call these conversion factors. But which one am I going to use? I'm going to have to take my 600 minutes and multiply it by a conversion factor. Which one should I select? This one or this one? Well, here is the answer. Okay, so notice here I have 600 minutes. Really, you want to think of this as a fraction, 600 minutes over 1. So the deal is this. Anytime you're converting from one unit to another, okay, here I want to get rid of minutes and be left with hours. So when I multiply these two fractions, I'm going to have a minute in the numerator and a minute in the denominator. These minutes can cross cancel. Okay, so this is the deal. You want to look at what conversion factor will cross cancel the unit of measure you're trying to get rid of. So instead of using this one here, if I had minutes in the numerator and hours over here, I would have minutes times minutes. I would end up with minutes squared. So be very careful when you're working with conversion factors. So we're going to cross cancel minutes here, and we're going to be left with hours. That's why you have 600 over 1 times 1 over 60, which is the same thing as 600 divided by 60 hours, which of course is 10 hours. Now, a lot of you, because this is so easy, you're like, oh, there's 60 minutes in 1 hour. You know, you could just do this mentally and do this math. But if I gave you more challenging units of measure to convert, believe me, you would have to go ahead and go through this process. So, you know, when you watch my videos, what I try to do is really fully explain all the different sub-skills that you need to be successful in these type of problems. But listen, if you need more help with word problems, you know, you need to do what? You need to practice. It's impossible to get better at algebra problems or math word problems by just doing one or two of them. Be like, okay, I get it. I can just handle any word problem that comes my way. No, you want to do a wide variety of problems because you're going to find patterns. If you're at that level of math with pre-algebra, algebra 1, this is algebra 2, I'm telling you right now, there's patterns in these type of problems. There's very classic type of traditional problems that you're going to see. You're going to see rate and time problems, proportion problems, time problems. And if you know how to do one, then that's going to give you a lot of hints on how to solve other related type of problems. So you got to practice, practice, practice. And if you need more practice, I have additional word problems on math word problems on my YouTube channel. But in all of my math courses, I have a lot of word problems, and word problems are also related to the particular topic you're learning. If you're learning about systems, there's systems word problems. If you're learning about quadratic equations, there's quadratic equation word problems. That's why you can't say, hey, look, here's a bunch of word problems. It all depends on what level of math you're at and what topic you are studying. But if this particular video helped you out, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.